One of the key use cases of the Tycho software is to facilitate the recovery of and the follow-up of newly discovered objects. And this would include objects on the neo-confirmation page of the Minor Planet Center website. Now, a lot of these objects will have high uncertainty, not just in their position, but also in their motion. And that is where the synthetic tracker can come into play, where you can specify a range of motions to search for, and that's very helpful. However, even though it is able to also evaluate its quote-unquote confidence in those objects, a lot of the times when you are doing follow-up of these very faint objects, they have very faint, very low signal to noise ratio, and so you're oftentimes at the very edge of detection where that object that you're trying to follow up on may very well have what it considers to be, again, a low confidence. And that's just based upon it having very low signal to noise ratio. So for those kind of objects where, again, you're just kind of at the threshold there, but you'd still like to be able to follow up on it, then that's where it would also be helpful to know if you are, in fact, looking in the right location. And so to that end, I have added a new feature to Tycho that overlays what we call the uncertainty map directly on top of the image. And so this will help instill confidence that a given detection, a given candidate detection, is likely to be that of the object that you're trying to follow up on. So if you've played around with the neo-confirmation page or used it to any extent at all, you might be familiar with this uncertainty map, is what they call it. So here you can see two different views. The one on the left is essentially a zoomed out version of the one on the right. And so here on the horizontal axis you have the right ascension offset, and on the vertical axis you have the declination offset. And the way this works is that they compute a given nominal orbit of the object, and they will base that upon however many observations they currently have available. And they will also compute over 1,000, typically over 1,000 other candidate orbits of that object. And so from each one, with its own orbital elements, they can integrate those to a particular point in time, and then plot all of those candidate positions that the object might take on. And so here you see a given object here. This is the uncertainty map for this object, and this is a plot based on just 4 observations. It's newly discovered, and here they have over 1,700 candidate orbits of that object. And so what would be nice is if we could then have some way to overlay this map directly on top of the image that we've taken, so that we know if we are in the right location for follow-up. So as it turns out, that is what I have just done. That's a new feature just added into Tycho just recently with version 8.7. And so I'd like to take just a brief moment now to explain how to get the most out of this feature. Okay, so the first thing you want to do is open up the image viewer with at least one image, and then navigate to Uncertainty Plot from the View menu. And this will bring up a new window, and you can type in the label of the object that is on the neo-confirmation page. And then you can specify how you want that plot to be computed. If you want it to be relative to the first image in your sequence of images, the last image, or the midpoint of those two. So this is an option as to where it will plot. You can also apply an offset if you wanted to, adjusting how many days, hours, minutes, and seconds. But for now, I'm just going to show the basic starting point here. So click Generate Plot, and that will make use of, again, all of those candidate orbits, and it will integrate them. And as you can see, it's pretty quick to do so. And if you want to, you can click on Go to Nominal. So that'll just go ahead and automatically center the cursor, or the crosshairs rather, to that nominal orbit. So from those 4 observations of that object, this is the uncertainty plot. So you can see, if you zoom out a bit, you can see that it could potentially be in this location here, but most likely it's going to be somewhere around here. again, closer to that nominal orbit. So this is, again, a nice feature to have just to instill confidence that when you are working with the synthetic tracker or through some other means of detecting that object, that you have in fact identified the correct signal associated with that object. So it's a nice feature. Now what I'm going to do is just show a comparison. Again, this is the uncertainty map with just 4 observations. Let's take a quick look and see what happens when we have additional observations. Okay, so the object that I'm going to take a look at here is a periodic comet 2021 U3. So it has by now a large number of observations on it, so we expect it to have very low uncertainty. So I'll go to View Uncertainty Plot, and I happen to recall the initial track label of that object. So this would have been the label for that object when it was on the NEO confirmation page. And so you type in again that label, and then just to start off with, I will use these settings and click Generate Plot. So it's going to download those candidate orbits, and then from that it will then integrate them to the epoch associated with, again, the beginning of the image sequence. So you can already see that it populated a cluster of plots right here, but if we want to, we can just go ahead and click this Go to Nominal button here. It'll take us directly to that, and if we zoom in, then we'll start to see again kind of that presentation that we saw earlier, but again more finely constrained because it has such low uncertainty. So as I zoom in, you can kind of start to see that. Again, it's a very, very low uncertainty at this point, again because we have a large number of observations on this object. In other words, the orbit of that object is well known at this point. So now you might wonder, well, where exactly, if we're expecting this to be the object, how come I can't see it? So one, yes, you can toggle this on and off, so that's helpful. But again, you're probably wondering, well, why am I still not seeing the object? It's a very faint object in these images, in fact. But I can go ahead and show you real quickly. Again, I can go to Tools, Download Observations. This is simply one way to do it. So if I knew the motion of the object, and it's by now a confirmed object, then I could type in speed, position, angle, and create a custom stack that way. Or this way, I can pull up Find Orb, attach it to the data set here of this object, and then right-click and choose Create Stack from Ephemeris information. So I've just now created a stack, again from the solution presented by the Find Orb software. So it has a given speed and position angle, and so all we've done here is we've stacked these frames associated with that motion. So this is in fact the object. If I adjust the contrast, you can potentially see it a bit better. So that is the periodic comet, and if I click on show the uncertainty plot, then this is what you get. Now again, this is relative to the beginning of the image sequence, but we've stacked the images now, and when we create a stack of all of the images, it's going to stack them relative to the midpoint. So if I wanted to, let me first go ahead and click Go to Nominal. I can create a marker here, and just that's simply a way to quickly save that position. Now let's try it midpoint sequence. Click Refresh, and you can see now this is where the object is expected to be at the midpoint in the image sequence. So I can create a marker too, you can see that. But anyway, if I uncheck this, you can see again, this is exactly where the object is expected to be. So if I toggle on the uncertainty plot, you can see it lines up exactly where the object signal is in the image. So that's kind of cool to see that. And so again, that's what it looks like when you have an object with very low uncertainty. It's far more compressed together as compared with the previous example where the object could have been had high offsets in both right ascension and declination. So anyway, that's a nice feature to have where you can again instill some confidence that the object that you're trying to follow up on is located where you have found a given signal. So that's about it for this video. So thank you for watching, and see you next time.